Throughout history, art has been used as a wonderful way for artists in every era to represent historical, religious, or fantastical figures or scenes. Especially in modern times, we see artwork of all kinds in shapes and sizes made from a variety of mediums. But how can something with such perfect film-like consistency be made in the first place? And why is it so important for the artist to carefully consider what medium they use in their art? The answer lies within its chemistry. For the purposes of this video, I will be analyzing the chemistry of paints that are more commonly used on canvases, such as acrylic paint, spray paint, watercolors, and oil paints. I will also be analyzing the possible health issues that can occur from these paints, and what chemical substances will cause these issues. Let's start by talking about acrylic paint. Acrylic paint is more commonly found on canvas art in modern times because of its faster drying time, solubility in water, and widespread applicability to various surfaces, especially canvases. It is commonly composed of pigments, acrylic polymer medium, and water, with the ratio being about 41% water, 32% polymer binder, and 6.5% pigments, including additives, but can fluctuate depending on the company creating the art and composition of each paint color. The specific acrylic polymers, also known as copolymer binders, can include methyl methacrylate, ethyl acrylate, and N-butyl acrylate. These polymer binders make up the liquid part of paint that gives paint its drying abilities, and will simply be called binders throughout the rest of the video. Furthermore, the chemical compounds that make up the different colored pigments all commonly have cadmium sulfide, crushed pure cobalt powder, carbon charcoal, titanium dioxide, different iron oxides, and much more. This is what gives the paint its specific color, depending on the presence, absence, or mixture of these compounds. Acrylic paint can also be separated into different subcategories based on the amount of light reflected, which includes satin acrylic paint and matte acrylic paint. Satin acrylic paint has about 25 to 30% shine, making it more popular for finishings. On the other hand, matte acrylic paint has about 5 to 10% shine and reflects little to no light. This is due to the higher amount of resin and binders being present in satin acrylic paint versus matte acrylic paint, which has a low resin component in the formula. Spray paint is very similar to acrylic paint in its composition of water, pigments, and binders, but differs in its application. In recent years, spray paint has become particularly popular in creating indoor and outdoor murals, but can also be found on canvases. The main difference, though, is that spray paint has different types of binders, which would explain why the drying time and composition of spray paint is slightly different than that to acrylic paint. If we look at alkyd resin spray paints, the main binders include alkyd nitro and alkyd. For styrene acrylic resin spray paints, the main binders include 2-ethyl hexyl acrylates, methyl methacrylate, styrene, alpha methylstyrene, and butyl methacrylate. And finally, for styrene-based spray paints, alpha methylstyrene and styrene were found to be the main binders. What makes spray paints so particularly unique, though, is the idea that the paint is able to be propelled out of a spray paint can, which is the common application method. This is caused by an addition of either dimethyl ether or a mixture of propane and butane. And if a mixture of propane and butane is chosen to be the propellant, then most likely there will also be white spirit or acetone present in the solvent. Everything else, on the other hand, specifically the chemical compounds that colorize paint, is going to be the same as it is for acrylic paint. The next type of paint that we will be looking at are watercolors. Watercolors tend to be more popular because they are easy to use on paper materials due to the high absorbency of paper, especially when they're being used on watercolor paper. They were also popular because someone can continue to reactivate the watercolor pigments for a long time with just the addition of water. This is because watercolors are overall made up of pigment particles suspended in water. Furthermore, watercolors can be made with either pigments or dyes for the color. Pigments are not soluble in water, though, and are used by professional watercolor companies to create watercolor dry cakes. On the other hand, dyes are soluble in water and are used by liquid watercolor brands to create liquid watercolors. Overall, the dry cake watercolors are made of the same pigments used in acrylic paint, and then preservatives, often formaldehyde, and binders such as gum arabic or gum tragacanth are also added. For liquid watercolors, they will additionally contain water, glycerine, glucose, and other materials. Furthermore, to go into more depth of what gum arabic is, it is a pH-neutral salt of acidic polysaccharides. and can contain potassium and magnesium, but mainly consists of calcium. It is one of the more abundant polysaccharides that can be found in nature and has excellent water solubility, which can offset the insolubility of pigments that are commonly found in watercolors. Finally, our last type of paint being discussed is oil paint. Oil paints have been popular for centuries, yet a newer and cleaner form of oil paint has started to become more popular in recent years. These can be less popular than acrylic types of paint, though, since it has a longer drying time, but one may prefer to utilize its versatility to paint the inside or outside of their house, or for another kind of renovation, since it is suitable for either wood or metal surfaces. Modern oil paints are overall made from oil binders such as linseed, which is a natural or alkylate synthetic kind of oil, with turpentine and white spirit added to increase the viscosity or the thickness and density of the paint. Linseed oil is more often preferred because of its flexible properties and resistance to cracking, but can yellow with age. Other oils, on the other hand, like walnut oil, poppy oil, and saf oil, are less prone to yellow with age, but aren't as popular because they have thinner and more watery properties, not to mention they often crack before drying. Oil paints are particularly unique in the way they dry though, since the oils utilized in oil paints are made up of fatty acids and therefore are not soluble in water, so they do not dry like water. For example, linseed oil, which is the more popular type of oil found in oil paints, usually contain the following fatty acids: about 48 to 60% linolenic, 14 to 24% oleic, 14 to 19% linoleic, 6 to 7% palmitic, and 3 to 6% stearic. So oil paints dry due to a property called sedative quality, which is where they absorb oxygen from the air and harden because of it, otherwise known as auto-oxidation. If the paint layer is applied too thinly and is accelerated by a sedative, the paint can crack through. This is especially true due to the top layer of the paint oxidizing faster than the bottom layer, since it is more exposed to the surrounding oxygen. But when this top layer of the paint oxidizes, it expands and doesn't leave room for the bottom layer to expand. This entrapment of the bottom layer therefore leads to cracks in the paint. To create the different colors, different pigment particles are mixed into the oil paints, which are commonly made up of mineral salts, like zinc oxide, titanium dioxide, and the red to yellow cadmium pigments. Now, after analyzing the chemical components of the different paints, we can now focus on the possible health issues that may arise from misusing or not safely using these paints. First, acrylic paints and spray paints can contain a certain chemical called formaldehyde, which is a colorless, strong-smelling gas when secluded, and is meant to serve as a preservative for paint. Watercolors, on the other hand, can have a polymeric form of formaldehyde. Acrylic paints, spray paints, and watercolors may also have the presence of ammonia. The presence of any form of formaldehyde in ammonia is important because it can lead to allergic reactions in eyes, nose, and throat irritation. In addition, spray paint can also contain volatile organic compound fumes, or VOCs, which are made up of acetone, xylene, and toluene. Short-term side effects from long-term exposure can include eye, nose, and throat irritation, headaches, loss of coordination, and nausea, while long-term effects include damage to the liver, kidneys, and central nervous system, and on the far end, some organics are suspected to cause cancer. Alas, while it may lead to respiratory irritation and allergic reactions, acrylic paint and watercolors are much safer than oil-based paint. Some oil paints can contain heavy metals such as lead, mercury, cobalt, and barium, which is a part of the pigments, and can lead to poisoning. Poison symptoms include, but are not limited to, blurred vision, eye and nose irritation, rapid heartbeat, cough, shallow breathing, coma, confusion, depression, dizziness, headache, irritability, lightheadedness, nervousness, decreased level of consciousness, blisters, burning feeling on skin, itchiness, numbness or tingling, abdominal pain, diarrhea, nausea, and vomiting. Overall, while paint may be beautiful and highly desired to be utilized to create art, one should not forget to take proper safety precautions, such as painting in well-ventilated locations and using an exhaust fan to remove fumes, avoid open flames and never smoke while painting, use safe paint products, clean up and dispose of paint properly when finished, and properly store excess paint by keeping it sealed and in room temperature. Furthermore, this is why an artist's decision of what paint they decide to use is so important. Each painter has their own unique goal of what they want to get out of their art, which has led to the creation of many different paints with different chemical compounds, properties, results, and also different side effects. The paint that an artist uses can have a major impact on what the end result of the artwork will look like, and can also impact the health of the artist if they choose their paint poorly. Overall, the lesson to be learned here today is always research your paints, especially their health drawbacks, before you use that paint in your personal artwork. And that concludes this video about the chemical components involved in paint. Thank you for tuning in, and I hope that you learned a lot from watching.